Hello everyone, in this presentation we will be talking about the electric current. So basically, what is electric current and where does it come from? So before going towards the definition of electricity, let's consider if we have a conducting wire set isolated on a table. So if you cut this wire on an imaginary plane like this, then you would be amazed that there is a movement of electron from this imaginary surface or from this imaginary area. But this movement of electron is random, because the number of electrons flowing from this imaginary area in one direction is equal to the number of electrons going through this imaginary surface on the other direction. So the net flow of charges is equal to 0. So we can say that we assume that this conducting wire is a dead wire, but actually there is a random movement of electron inside this conducting material. So if you want to align these electrons in one direction, so we need to apply a potential difference or voltage source. So let's consider. So if we connect this copper wire or conducting wire across the terminal of the battery, so as a result, these electrons are aligned towards the positive terminal of the battery, and through chemical reaction it goes towards the negative terminal of the battery, and it is reflected again into this conducting wire, and the process is go on. To understand this process in a more brief way, let's consider an example in which we have a simple circuit in which a bulb is connected through copper wire across the battery terminals, and the electron from the battery terminal would drift to this conducting wire and passes through the filament of these bulbs and then goes towards the positive terminal of the battery, and then a chemical action occurs, and this electron goes toward the negative terminal and then again goes towards the filament of the bulb, as a result of which the filament of the bulbs getting heat, as a result of which the bulb is glowing. So if we cut this copper wire on an imaginary surface and zoom in this surface, then we see that the electron is passing through this surface. So actually this flow of electron from any imaginary area per unit time is called the current, or we can simply say that the flow of charges through this imaginary surface is called the electric current. So we define the electric current as, which states that the number of charges passing through any cross-sectional area per unit time is called the current. In this cross-sectional area, the number of electrons which is passed through this cross-sectional area per unit time is called actually the current. So we can write down mathematically the current as, so the current is represented by I, which is equal to the number of charging passing through any cross-sectional area per unit time is called the current. So we discussed in the video of electric charge that the larger symbol represents the quantities which doesn't varies with time. So by this Q we means that the number of electron which passes through this imaginary surface is constant. So the constant number of electron passing through this surface per unit time. Or if the rate at which this charge is flowing through this cross-sectional area is changes, then this is called the instantaneous current, and we represent the instantaneous current as, or we define the instantaneous current as, so the rate at which the charges flow changes with time, so that current is called the instantaneous current, and which is represented by a small I, which is equal to the rate of change of charge. So talking about the unit of the current, so we know that the unit of charge is coulomb and the time is second. So the unit of current is coulomb per second. The other unit of current is ampere, which is represented by a capital letter A in the honor of Henri Ampere. So the current through this imaginary surface is said to be 1 ampere if 1 coulomb of charge passes through this imaginary surface in 1 second. So we can say that 1 ampere is equal to if 1 coulomb of charge passes through this imaginary surface in 1 second. And we know that 1 coulomb of charge contains 6.3 multiplies 10 raised to the power 18 electrons. So if 6.3 multiplied 10 raised to the power 18 electron passes through this imaginary surface in 1 second, then the current said to be 1 ampere. A simple question which arises in everyone's mind, that which came first, egg or a chicken? It is just for your attention to driving towards the fact that which arises during the study of the voltage and current, because a layperson has a tendency to use both voltage and current interchangeably if both were the sources of energy. So now it is time to set things right or straight. So we can say that the applied voltage is the starting mechanism, while the current is the reaction to the applied voltage. Or we can simply say that the applied voltage or potential difference in any electrical electronic system is the pressure to set the system in motion, and the current is the reaction to that pressure. So we can simply say that if we connect the conductor across the terminals of the wire, so this battery would, or this potential difference source, will apply a pressure on the free electron which exists in this conductor, which is, we simply says, the action. And as a reaction, these electrons start moving in this conductor from negative towards the positive terminal of the battery. Okay, if you look into this figure, you will analyze that there are two kinds of current which is flowing. The one is flowing from the negative terminals towards the positive terminal of the battery, which we already analyzed. But there is another current which is flowing from the positive terminals toward the negative terminals of the battery. So what is this current? This current is actually called the conventional current. So in a conventional current, we consider that the current exists in the conductor due to the flow of positive charges, and this is basically called the conventional current. But in any ordinary current, we know that the current is flowing from the negative terminal towards the positive terminal, and we are all sure on this point that the current is due to the negative charges. This conventional current was discovered during the discovery of electricity. So let's define this electronic and conventional current. So basically, what is electronic current? The current in an ordinary conductor is due to the displacement of or flow of electrons, which is true. And we define the conventional current as, so the current was conceived of as a stream of positive charges. Or we can simply say that the electric current is due to the flow of positive charge. So this conventional current is discovered during the discovery of electricity. So it was Benjamin Franklin performed this experiment. He flew a kite during a thunderstorm, and he tied a metal key on the middle of the string. And as suspected, the current or the electricity from the thunderstorm flowed down towards the string, which is wet, and Franklin received a shock. He was very lucky not to have received a shock, but he proves his idea, and on that time he conceived that the current is due to the motion of positive charges, on which we say that the electric current is due to the flow of positive charges. So from that time, the convention is made that the current is due to the flow of positive charges, and which is flowing from positive terminals toward the negative terminal. But the electronic current, but actually in a conducting material, the current is due to the electron flow or negative charges flow, which is from the negative terminal of the battery towards the positive terminal of the battery. But we don't need to confuse about the electronic or conventional current, because they produce no difficulty during the analysis. Once we set the direction of a current, then we should to carry on our analysis. But we will be using the conventional current because this current is widely used in educational studies and industries also, and also in making the computer softwares. Basically, there are two types of currents. The one is called a DC current or direct current, and the other one is called the AC current or alternating current. So we can define the direct current as the current in which the flow of charges is constant. So basically, the current in which the flow of charges are all in one direction for any period of time. From the graphical representation, the DC current is defined. So the flow of current is always constant for any period of time. So moving towards the alternating current. So what is alternating current? So the type of current in which the flow of charges changes or reverses the direction periodically. By periodically we means that which reverses its direction at equal interval of time. So graphically we represent the AC current as. So graphically it moves in one direction then reverse its direction, and both the direction are having the same magnitude. So as the average of these both direction are equal to 0. So it's all for today's lectures. So if you have any doubts, ask in the comment section. See you in the next one.